Hi, Mr. Killian. This is Sammy, and I'm retaking the first probability quiz. So for problem 1A, you have to realize that order is important, so you can't use C's. So you have 5 choices for the first letter because those are the 5 vowels, 4 choices for another letter because you can't repeat, and that's the number of other vowels that there are, and then 23 choices for another letter because you can't use C and you can't repeat the 2 vowels that you used, and then 22 choices for the next one. And then you have to multiply those together and then divide that by the total number of ways that you could arrange 4 letters, which is 26p4, to get 11 over 390. To find the probability of getting 2 cards that are the same color, you have to first do the probability of getting 2 cards that are either red or black. So because of this, and without replacement, so because of this, you have to do 1/2 because that's the number of red or black cards are, and then since you don't replace it, 20 times 25 out of 51. But then you have to multiply it by 2 to take into account that there are 2 colors, 2 ways that you could get this because there are 2 colors. To find the probability of having 2 cards that are 7 or 8s or one of each, you have to realize that there's 8 7s or 8s in 7s and 8s in the deck. So you do 8 out of 52. And then since you don't replace it, you multiply that by 7 out of 51 because there's 1 less card. So for 5, since you're only doing 1 card and it has to be 7s or red, you have to add the number of red cards plus the number of 7s that aren't red cards. So that's 28 out of 52, and then that's the answer, and it simplifies to 7 out of 13. For number 7, since you have to find whether 2 events are independent, you have to know that for an event to be independent, the probability of having a dog times the probability of having a cat must equal the probability of having a dog and a cat. So 82 out of 200, which is the probability of having a dog, is 0.41, and 66 out of 200, which is the probability of having a cat, is 0.33, and the probability of having both pets is 18 out of 200, which is 0.09. So 0.41, you multiply 0.41 times 0.33, and that does not equal 0.09, so the events are not independent. So for 8A, you have to determine what the probability of the starting center making exactly 4 free throws out of 7. So this is a Bernoulli trial because each shot is independent of the last one. So for that, you have to multiply 60%, which is 0.6 to the 4th times 0.4 to the 3rd, because you have to account for both things to get the right probability, and then you have to multiply that by 7C4 so that you indicate that you're choosing 4 places where the good shots can go and 3 where the bad shots go that miss.